From the vast expanse of space, our Earth appears as a tiny blue dot, a fragile oasis teeming with life amidst the cosmic darkness. It is a humbling perspective that underscores the sheer scale of the universe and our relatively insignificant place within it. Yet this pale blue dot is our home, the only known abode of life in the vast cosmic ocean. It is a world of wonders, a delicate balance of land, water and air that sustains an incredible diversity of life forms. Our planet is a marvel of cosmic proportions, a celestial body in constant motion, spinning on its axis and orbiting the sun at incredible speeds. Despite its apparent stillness from our perspective on the surface, Earth is a dynamic and ever-changing world. From the slow, grinding movements of tectonic plates that shape continents to the powerful forces of weather and erosion, our planet is in a perpetual state of flux. Understanding our place in the universe begins with appreciating the scale of our own planet. Earth's diameter is a staggering 12,742 kilometers, a distance difficult to comprehend from our earthbound perspective. If we were to circumnavigate the globe at the equator, we would cover a distance of roughly 40,075 kilometers. To put that into perspective, that's like traveling the length of the United Kingdom nearly 17 times. These numbers, while impressive, are dwarfed by the vastness of space. As we venture further from our home planet, the distances become increasingly difficult to grasp, pushing the limits of human comprehension. But it is in this exploration of the cosmos that we truly begin to appreciate the grandeur of the universe and our place within it. Our closest celestial neighbor, the Moon, has captivated humanity for millennia. Its silvery glow in the night sky has inspired countless myths, legends, and scientific inquiries. But the Moon is more than just a celestial spectacle. It is a celestial body in its own right, a world of craters, mountains, and vast plains of solidified lava. The Moon's average distance from Earth is about 384,400 kilometers. That's roughly 30 Earths lined up side by side. To reach our lunar companion, traveling at a speed of 100 kilometers per hour, it would take us a little over 160 days of non-stop driving. This journey highlights the immense distances involved even within our immediate cosmic neighborhood. Despite its close proximity, the Moon is a world vastly different from our own. Its surface is a barren landscape devoid of air and water, scarred by countless impacts from asteroids and comets. Temperatures on the Moon fluctuate wildly between extreme heat and frigid cold, making it an inhospitable environment for life as we know it. Yet the Moon plays a crucial role in shaping our planet. Its gravitational pull is responsible for the tides, the rhythmic rise and fall of ocean levels that have influenced life on Earth for billions of years. The Moon also acts as a stabilizer for our planet's axial tilt, preventing drastic shifts in climate that could have rendered Earth uninhabitable. Our lunar companion is a testament to the power of gravity, a force that shapes the cosmos and binds celestial bodies in an intricate cosmic dance. As we continue to explore the Moon, we uncover more secrets about its formation, its history, and its profound influence on our own planet. At the heart of our solar system lies the Sun, a colossal ball of burning gas that bathes our planet in light and warmth. This celestial powerhouse is the source of all life on Earth, its energy driving the processes of photosynthesis that sustain the planet's intricate web of ecosystems. The Sun's distance from Earth is about 149.6 million kilometers, a distance often referred to as 1 astronomical unit or AU. Light, traveling at a mind-boggling speed of approximately 299,792 kilometers per second, takes a little over 8 minutes to reach us from the Sun. To put that into perspective, if we could travel at the speed of light, we could reach the Sun in a little over 8 minutes. However, even at the speed of light, the Sun's immense size is difficult to comprehend. Its diameter is about 1.39 million kilometers, making it roughly 109 times wider than Earth. To put that into perspective, if the Sun were the size of a standard door, Earth would be about the size of a 5-pence coin. The Sun's energy is generated through nuclear fusion, a process where hydrogen atoms are converted into helium, releasing enormous amounts of energy in the process. This energy is radiated outwards in all directions, reaching every corner of our solar system. It is this energy that sustains life on Earth, driving the weather patterns, ocean currents, and the very processes that make our planet habitable. Mars, the fourth planet from the Sun, has captivated human imagination for centuries. Its distinctive reddish hue, visible even to the naked eye, has earned it the moniker the Red Planet. This celestial neighbour has long been a subject of fascination, fueling dreams of extraterrestrial life and inspiring countless works of science fiction. Mars' distance from Earth varies greatly depending on the two planets' positions in their respective orbits. At its closest, Mars can be as near as 54.6 million kilometers. However, at its farthest, the distance stretches to a staggering 401 million kilometers. This vast difference in distance poses significant challenges for space travel and communication. Despite these challenges, Mars remains a prime target for exploration. Its potential for harboring past or present life, coupled with its similarities to Earth in terms of its day-night cycle and axial tilt, make it a compelling destination for scientific inquiry. Evidence suggests that Mars was once a much warmer and wetter planet, with flowing rivers, vast oceans, and a thicker atmosphere. Today, Mars is a cold, dry desert world, its surface battered by solar radiation and its atmosphere a thin veil compared to Earth's. However, beneath its barren exterior, Mars may still hold clues to the early solar system and the potential for life beyond Earth. Section 5. At the edge of our solar system, Neptune. Neptune, the eighth and farthest known planet from the Sun, marks the outer boundary of our solar system. This icy giant, a swirling blue behemoth, lies at an astounding distance of approximately 4.5 billion kilometers from the Sun. This vast gulf is a testament to the immensity of space and the incredible scale of our cosmic neighborhood. Light, the fastest thing in the universe, takes about 4 hours and 15 minutes to travel from the Sun to Neptune. This means that if we could send a message at the speed of light, it would take over 4 hours for it to reach this distant world. This vast distance highlights the challenges of exploring the outer reaches of our solar system. Neptune, named after the Roman god of the sea, is a world of intense storms and supersonic winds. Its atmosphere is composed primarily of hydrogen, helium and methane, giving the planet its distinctive blue color. Beneath its swirling clouds lies a frigid ocean of water, ammonia and methane ices. This distant ice giant, though faint and difficult to observe from Earth, plays a crucial role in shaping the dynamics of our solar system. Its gravitational influence extends far beyond its icy realm, affecting the orbits of comets and other objects in the Kuiper Belt, a region of icy bodies beyond Neptune's orbit. Section 6. A Voyager's Tale. In the annals of space exploration, few missions have captured the imagination quite like Voyager 1. Launched in 1977, this intrepid spacecraft has spent over 4 decades journeying through the cosmos, pushing the boundaries of human ingenuity and revealing the wonders of our solar system and beyond. As of today, May 15, 2025, Voyager 1 is the farthest human-made object from Earth, a testament to the enduring spirit of exploration. It has traversed a staggering distance of over 22 billion kilometers from our planet, venturing into the uncharted territory of interstellar space. To put that into perspective, if Voyager 1 were to send a message back to Earth today, it would take over 22 hours for it to reach us, traveling at the speed of light. Voyager 1's journey has been nothing short of remarkable. It has flown past Jupiter and Saturn, capturing stunning images of these gas giants and their moons. Its observations have revolutionized our understanding of these planets, revealing intricate details about their atmospheres, magnetic fields and ring systems. In 1990, Voyager 1 turned its camera back towards Earth, capturing the now iconic pale blue dot image. This photograph, showing our planet as a tiny speck of light suspended in a sunbeam, has become a powerful symbol of our place in the cosmos, highlighting both our insignificance and our interconnectedness with the universe.